Our next presentation is Digging into the Dirt, the Evolution and Impact of Crop Rotations. Rigas Karamanos received his BSA from the University of Thessaloniki, Greece, and his Master's of Science and PhD in Soil Chemistry and Fertility from the University of Saskatchewan. Rigas is the Senior Agronomist with Koch Fertilizer Agronomic Services in Canada. He was granted a Fellow and a Distinguished Agronomist Award in the Canadian Society of Agronomy in 2013 and 2019, respectively, and was inducted into the Saskatchewan Agriculture Hall of Fame in 2015. Welcome, Rigas.
Oh, thank you. So I'm going to be covering a little bit about the evolution and impact of crop rotations. And if you go back in history, it's really amazing. Back in, there was a conference in the United States back in 1926, and there was a scientist there, Dr. Weir, that said that it's exactly what he said. Modern crop rotation was established about the year 1730 in England. It's amazing. Oh. Okay. And in general, it consists of a cultivated or intertilled crop, a small grain, and a grass or leguminous crop grown in the order named. So that's when rotations were established back in the 1730. Now, what aspects of crop nutrition are we talking about? We're talking about direct benefits or detriments and indirect benefits or detriments. And also the quantification of crop nutrition benefits and detriments in crop rotations. So major emphasis will be given on nitrogen and the phosphorus and the sulfur. So when it comes to direct and indirect benefits and fixing crops in a rotation, the direct benefit is that less nitrogen fertilizer requirement subsequent to the, especially pulse crop. Nitrogen credits the following year and plan on seeding to low nitrogen soils. And then impact on soil properties will be soil organic matter, increase in soil or maintaining the soil organic matter levels. And of course, when you improve the soil organic matter, you also improve what glues soil particles together and improves the soil structure. When it comes to detriments, on the other hand, the nutrient levels following a non-leguminous crop can be, especially forages, can be very low. Nutrient and available water levels following very high yielding crops can be lower, and that's, especially when you grow canola, and now the new cultivars of canola with 80 bushels and so forth, they suck up a lot of water. And nutrition affected by crop types, especially non-mycorrhizal versus mycorrhizal crops, and I'll come to that at the end of the presentation. Now, also, nutrient status after breaking, the soil test levels, particularly those ones of phosphorus, can be extremely low following breaking of alfalfa. And actually, when you break alfalfa, you have to really fertilize. If you have alfalfa for 5, 6 years, and you decide to break and start growing cereal or any other crops, you better watch your phosphorus levels. Can be quite low. So when it comes to the identifying the benefits of putting legume crops in a crop rotation, and you can see they will add some yield. I did bring my pointer, but it'll point on the black, but not on the on the white. So sorry about that. It's not going to be of any use, I'm afraid. So anyway, the benefits can be a number of them. Disease suppression, better seed beds, improved soil moisture in some cases, earlier seeding, weed control, and of course, improved soil fertility, which is what, is the major emphasis of this presentation. So now I'm going to talk about a number of influences of crop rotations. And I'm going to start, first of all, with tillage and residue management. So when it comes to tillage, when we incorporate crop residues, incorporation of crop residues, pesticides, and preparation of the seed bed, and of course, green manure crops require tillage. When it comes to crop residue, managing residue for erosion and to also adequately seed and fertilize, baled or spread, and flax stubble, and I'll come back to that at the end as well. When it comes to influences of crop rotations, available resources, organized resources such as labor, land, machinery, management, as well as capital. Spread workload, it also requires intense management, access to information. Crop grown will depend on equipment, and of course, if there is irrigation pivots and baler. When it comes to influences of crop rotation or risk management, here is a canola example. Amount of risk taken depends on the producer experiences, attitude, and financial position. Production risk and market risk, various crops with different seeding dates, pests, and commodity prices. So there is also influence of crop rotation on moisture availability. So rooting depth. So you can see that, did I miss one? Yeah, I'm sorry about that. So the moisture use efficiency varies with different crops. When you grow, on average, when you grow a bushel of wheat, that removes 4.2, bushels, or requires, 1 inch will lead on average to 4.5 bushels of wheat, whereas 1 inch of water will lead to 6.4 bushels of barley, 3.2 of canola, and 8.2 of oats, and that's average values. So when it comes to crops, with availability, crops have different rooting depths. So of course you have to take that into account, when you're growing a crop. For example, alfalfa and barley, after alfalfa, maybe barley is better. Wheat, canola, and then peas, lentils, flax, all these crops have different rooting depths. We had some trials that we found canola roots down to 6 feet, believe it or not. But anyway, you gotta keep that in mind. When it comes to moisture availability and maturity, you can see that when the moisture is limiting, then short season annual crops should be seeded and winter annual crops. And we've had, now this past year was an amazing year. It's just actually confusing in many instances, but we got some phenomenal yields. But go back 2-3 years ago, when it was so dry, so, you have to take that into account. So also when it comes to crop rotation, the influence of crop rotation on fertility management, nitrogen fixing crops in rotations, when properly inoculated. Nitrogen credits are given in the year following lentils, peas, and alfalfa. I'll give you an example in a moment. Nitrogen fixing crops should not be grown on land testing high on soil nitrogen. if you go back into the history and how the nitrogen, if you don't want to have more than 40 to 50 pounds of nitrogen in the top 2 feet, and the top foot, pardon me, when you grow pulses like peas, lentils, because that will reduce actually their growth. All of the nitrogen requirements of wheat should be provided, in the year following alfalfa. So again, I had a project where we had alfalfa, and after 6 years, we broke it down. And, of course, all the nitrogen requirements of wheat should be provided in the year following alfalfa, because alfalfa doesn't break down as fast as other legumes. So 2/3 of the requirements in second year, and in the third year, when most of the nitrogen from alfalfa is released, you put 1/3 of the required nitrogen. So keep that in mind, that when you grow alfalfa for a period, normally people grow 5-6 years, and you break it, there are benefits for a number of years coming from there. When it comes to nutrient fertility management, and the nutrient uptake and removal by different crops, and this is a table that summarizes the uptake of nutrients by wheat, canola, and alfalfa. You can see that the uptake, removal is what we remove with the seed. Uptake is what the crop takes both in the grain and the stubble and the roots, and the stubble, whereas removal is what we're taking with the seed, and of course it's removed from the field. So you can see how the removal of different crops, different yields would vary, and you can see that we remove a fair amount of nutrients through growing various crops. Also, the influence of crop rotations on weeds and herbicides. Make sure you rotate herbicides. Alfalfa, weeds haven't become resistant to a cutter bar yet. Crops with different life cycles, winter cereals, crops vary in their competitiveness with weeds, and keep in mind that caution on volunteer crops, they can grow also during the year. And also another thing to keep in mind, of course, will be residual herbicides, and of course you're very much aware of it. One more thing about is the insects. You gotta remember that most insects have host specificity, like wheat midge is wheat midge. It's specific to wheat. Crop rotations may have reduced effectiveness because of great traveling distances, long survival, several host possibilities, so keep that in mind. And so the other thing about influence of crop rotation will be on soil structure. And this is an experiment, I know it's an old experiment that was carried out back in the late 90s, but just building organic matter, nutrient supply, and microbial activity, soil permeability, aeration, and soil tilth, you can see how, at that time, of course, they had fallow. Now we don't have fallow. So this rotation is wheat and fallow, but you can see that the continuous wheat resulted in higher organic carbon. And of course, you multiply the organic carbon by 1.724, and you get your organic matter, so you have higher organic matter. So keep that in mind as well. And also, when it comes to influence of crop rotation on soil erosion, grow alfalfa or field peas to add organic matter. This is the top of the legumes that add organic matter to the soil. Permanent cover crop, double cropping, strip cropping, and of course eliminate summer fallow, which is something that I remember when I came to Canada back in the 70s and I was traveling, sometimes in the summer you couldn't see where you were going because of the dust in the air. Now it's, most of the time the summer fallow is incidental. It's not, Anyway, so, and one more thing of influence of crop rotation will be the soil erosion. You can see that the trash and the erodibility, the same thing with that. Yeah, anyway, and then the next thing would be soil pH. Crops are sensitive to adverse soil pH if the soils are either alkaline or acidic. So no which crop you should grow because, different crops have different, preference of soil pH. Also rhizobium, which is, for legumes, that's how they fix nitrogen, is also very sensitive to acidic soils. So you're not going to get a very good, growth in acidic soils. And finally, the last influence of soil crop on crop rotation will be soil salinity. Many times, you cannot change the saline land. It's kind of tough, but you can manage it. So do not fallow crop continuously. Soil-tolerant crops, and add organic matter to improve the structure and infiltration, because the salts, what they do is they push apart the soil particles and the soil structure breaks down. If we add organic matter, and that is done, the perfect way to add organic matter is to put manure, but we can't do that all over the place. But, the practical way is to use legumes, pulses. Another thing I wanted to mention is that the stubble type does not have any much influence on the yield. Yes, you're going to get greater yield responses of crops that were grown on pea stubble. You can see the line is greater. It's on top. It's 10 bushels more than what it is on wheat stubble and barley stubble. But the response, which is the change in the yield with adding fertilizer, in this particular case, side-banded nitrogen, you can see is the same. And that comes back from my Wesco days, back, the good old days. Anyway, so talking about Wesco days, I wanted to share with you the results of a crop rotation trial that we carried up that time on 2 different soils, dark brown and black. And when it comes to Manitoba, black is, is what we're talking about. And the experimental side was grown to 3 crops: peas, barley, and canola in the spring of the first year. Then the second year, we grew took wheat or barley, and we, scientifically, we used a split plot trial, and we also looked at tillage, and we looked at till or no till and 4 nitrogen rates. So we had wheat in the second year, and then barley in the third year, and we did not apply any nitrogen in the third year, because we wanted to see what is the impact of the application of growing legumes. So first of all, this is the impact on soil water. And the first one on your left is the dark brown soil zone, and on the right is the black soil zone. And the green is the pea stubble, the brown is the barley, and the orange is the canola stubble. So that is the impact of the soil water in the top 1 foot, and you can see that, and that is in inches. And of course, dark brown tends to be drier, but you can see that the barley stubble there was much higher. Not too much difference when it came to the black. The next one, the impact on soil test. And you can see that when we, that's in the black soil zone, that is more fit, more matching the Manitoba situation. There was the nitrogen pounds per acre. The brown is the nitrogen pounds per acre in the top 6 inches on September 5th. And the orange, it's on September 28th. So we went out after we grew the crop and we measured the soil test on the 5th and on the 28th, because that's how, there is, as long as the soil temperature is above 10, we keep on having mineralization in the soil. So you can see there were just about 40% more nitrogen after peas, 6.4% more nitrogen after barley, and 50% more nitrogen after canola. Interesting, isn't it? In the dark brown soil, it was 50% more, 51% more nitrogen after peas, 3.4% after nitrogen, and 36.1% after canola. So you can see that there is nitrogen being mineralized as a result of the crops, and when we have pulse crop in the rotation, that will be much greater. So that is the main, you can see now the yield, and the name there is covered is wheat yield in bushels per acre in the dark brown and black soil zones, and that's the pulse pea, the pulse stubble, the cereal stubble, and the oil seed. That's in the second year, and you can see it's kind of interesting that there was quite a bit of benefit from the canola stubble. That was very surprising. But you can see that in the third year, we got more benefit from having grown pulse in the first year. That nitrogen sometimes takes time to be released, and the real benefit showed up in the third year. So this is also the pulse benefit. You can see in the stubble, the bushels per acre. That is the benefit, the yield, with different nitrogen rates. When we did not apply any nitrogen, you can see in the second year we got 15 more bushels of wheat on the pea stubble than on the other, But when we apply nitrogen, you can see that the response on the pea stubble was not as great because we were using nitrogen, not the nitrogen from the peas. And also, there was a benefit from growing canola, But the third year, look at the difference, all this green, shows that how the pulse takes some time. It's not going to, the benefit is not going to be the next year. It'll be the following year. But when you have pulses in rotation, you do get a great benefit when it comes to nitrogen. And if you want to look at the pulse benefit, you can see that the pulse benefit in the second year, it was 44 to 49, 5 bushels on average. In the third year, 97 to 103 bushels overall. That was the pulse benefit. So also, why would we be growing perennial forages? Well, soil conservation is one thing, and that's a big thing now these days. Soil building, we're talking about building organic matter. Meat growing, domestic livestock demand in many areas. Also, reclaim marginal land. And finally, rotational benefits. All this, And here is a pulse example from Manitoba. It was carried out back in 2002 by Dr. Bulid and a number of other scientists, and he found that compared to non-legume crops and legume green manure, such as canola, single-year hay legumes, and legume green manure crops increased both yields and nitrogen uptake of the subsequent cereal crops by 25%. And that was carried out here in Manitoba, actually in Winnipeg. And here are the results from that study. I know I should have converted them to bushels per acre, but nevertheless, I went into the publication back in 2002 from the Canadian Journal of Plant Science and pulled that table for you. And you can see when it comes down that the major benefit was from chickling, veg, and lentil gave the greatest yield in year 1. You went into the year 2, there were not that spectacular differences. Dorman alfalfa, and again, the chickling veg and the lentil gave the best results. So this is really, really interesting. One more thing I want to do to complete my presentation is to talk about the impact of non-mycorrhizal crops in rotation. Well, I used to be working for Viterra, for Wesco, and while I was with Wesco, that was amalgamated by Viterra. What happened was Viterra used to have a 25-acre field north of Brandon where they were carrying out their trials. And then they decided in 2008 to turn this field over to the producer that they were renting it from. And the producer seeded flax that year in 2008. Well, I'm going to show you some pictures of the flax. Here are June 25th. And look at those. Dead spots, you can see that they're and you can see, so that's one, there is another one, there is another one, you can see again, that's on June 25th, and a close-up. So when the producer went to Viterra and told them, whoa, wait a minute, there is herbicide damage on that field, you got to fix it. So they invited me at that time, I was in Calgary still with Viterra. And I said, how can you spray herbicide in a perfect rectangle? There's no way you can do that. So, go to July 15th, you can see how the flax is growing, and those plots, they're not. So what we did at that time, we contracted, actually we gave funding to the Brandon University, Dr. McGonigal, and what he did is he sent out, he hired summer students that year, and they went out and they sampled. Isn't that amazing how those plots were way behind? And look at the difference between what was in those plots and what was, And again, August 20th, and more photos, look at the difference here. They're dead, pretty much. Well, the moral of the story is that when it comes to flax, it's a mycorrhizal crop, whereas canola is not a mycorrhizal crop. Mycorrhizae is microorganisms. They live in, it's not symbiosis, but they live together in the roots of the plants of lentils and corn. Keep that in mind. Of lentils, sorry. Flax. So what happens is mycorrhizae and there is a research that shows they take up phosphorus from the soil 3 times more effective than the roots themselves. So when you have a situation where you have flax or corn, that is also very much dependent on mycorrhizae, and there is no mycorrhizae in the soil, that's what happens. What you see here. Well, peas are non-mycorrhizal crops. So you grow peas for a year, mycorrhizae gets killed because they don't have, mycorrhizae have to live in, symbiosis together in the roots of the plants. And if you have a non-mycorrhizal crop like peas, mycorrhizae die. So the moral of the story is that where there were those, dead spots, it was the fact that mycorrhizae were dead and there was no phosphorus uptake. So we got this, the soil sample. They sampled in each plot, and also they took a shoot sample of 30 centimeter of flax row, and they used to estimate the shoot dry mass and shoot nutrients. And and here is some of the results. You can see that flax after canola was 1.12 tons per hectare. Flax after wheat was 1.8 tons per hectare. That's a lot of bushels. And then you can see root density was not that different, but you can see there were more mycorrhizae in flax after wheat, more hyphal colonization, over with flax after wheat. So you can see that what was the cause of that problem, that growing, canola, which is a non-mycorrhizal crop, killed all the mycorrhizae. So keep that, the majority of them. So do not grow, flax after canola. That's the moral of the story. Well, again, this is shoot nutrient concentrations, I'm going to look at nitrogen. Flax, it's much higher. Why? When you have lower yield, there is more nitrogen in the soil, in the plant, more concentrated. But look at phosphorus, again, everything. When you have lower yield, you got more nutrient in the soil. But, so, and the same thing here, the early season nutrient uptake by flax, this is the uptake now, not the concentration. You can see phosphorus, there were 4.6 kilograms per hectare with after wheat, whereas there were only 3 kilograms per hectare after canola. So you can see that the impact of canola on mycorrhizae and the impact of canola on the subsequent growth of lentils. So, and you can see the other, potassium was greater, sulfur was greater, you go some of the calcium, magnesium, some of the micronutrients too, like zinc, copper, boron. So there was there is a tremendous effect. So, in conclusion, this study showed that the previous cropping of canola restricts mycorrhizal development and of flax relative to that following wheat. What we did actually with the Brandon University, at that time we funded a 4-year project after that, and we established those rotations and came up with the same results. But anyway, the reduction is a mycorrhizal symbiosis is to the detriment of flax growth and early season nutrition of phosphorus, copper, and zinc. Moral of the story in red, do not grow flax after canola. So that's part of what we learned from the study that was carried out here, north of Brandon, and all the research that was done by Brandon University. So I thought I should leave you with that. Thank you so much for your attention here. I kept on time.
Time for questions?
Yeah, oh, absolutely. And that's my email. I even now get a lot of emails from people asking questions. Don't hesitate. I'm now.
Questions, if anyone has a question?
I confused you, haven't I?
I guess you did an amazing job.
Oh, thank you.
Thank you very much, Rigas.
Oh, my
Very
pleasure.
nice to meet you.
Thank
very,
you.
very much. Thank you. Don't forget this as well.
No, thank you.
All right.